every single pixel inside the Apple Vision Pro is the size of a red blood cell. Not a grain of sand, not a strand of hair, a red blood cell. And Apple somehow packed 23 million of them into 2 tiny panels, each no bigger than a postage stamp. That single fact right there is why this thing costs $3,500. And honestly, after you see what goes into building one, you might wonder why it doesn't cost more. Today, we're ripping open the most complex consumer device ever manufactured, step by step, layer by layer, to show you the insane 47-step process that turns raw aluminum, molten glass, and microscopic silicon into the Apple Vision Pro. Let's get into it. Section 1. The aluminum frame. It all starts with a bar of aluminum. Not just any aluminum, Apple uses a custom alloy, and the process begins with extrusion. That means heating the metal until it's soft enough to push through a custom-shaped die, like squeezing toothpaste through a nozzle. Except the nozzle costs hundreds of thousands of dollars, and the toothpaste comes out as 12-foot bars of precision-shaped aluminum. Those bars are then cut to length by an automated saw. Now, here's where it gets wild. That cut piece of aluminum gets loaded into a 3-axis CNC mill, where spinning cutting tools start hogging out the rough shape. We're talking about removing nearly 80 to 90% of the original metal, most of that aluminum recycled. But the frame that's left behind is a lightweight skeleton, designed to hold sensors and components with micron-level accuracy. After the initial rough cut, the part moves to a 5-axis CNC machine, one of the most expensive pieces of equipment in any machine shop. This thing doesn't just move left, right, up, and down. It can tilt, rotate, and carve free-form 3-dimensional surfaces that would be impossible on a standard mill. Apple uses this to sculpt the curves and contours of the Vision Pro's inner frame. Every pocket, every channel, every mounting point with tolerances tighter than a human hair. Then comes automated polishing. A robotic arm fitted with a melamine foam pad. Yes, the same stuff in a magic eraser buffs away every last machining mark. And if that's not enough, Apple hits the frame with laser ablation using focused laser beams to vaporize microscopic burrs and imperfections that no polishing pad could reach. After that, the aluminum goes through anodizing, an electrochemical bath that grows a protective oxide layer onto the metal surface, giving it that signature silver finish and scratch resistance. That's 8 steps just for the frame, and we're barely getting started. Section 2, the front glass. Now pay attention, because this part is genuinely insane. The front lens of the Vision Pro begins as a flat, precisely layered glass sheet. A CNC glass cutter, not your grandma's glass cutter, but a machine with live tooling that controls the blade orientation without even touching the surface first, slices it into shape. No lead-in marks, no burrs, just a perfect cut. That flat sheet then moves into a precision glass forming mold. The glass is heated past its softening point and pressed into shape under vacuum and heat, using a graphite mold that mirrors the final curved geometry of the front lens. This is the same caliber of process used to make $10,000 cinema lenses. The mold itself is modular, built with removable inserts so engineers can fine-tune positioning without scrapping the entire tool. Here's the brutal part. During this molding process, even one speck of dust will cause a visible optical distortion. One particle. If they spot it, they scrap the whole piece and start over. That's how tight the tolerances are. After forming, the glass goes through edge beveling on a 5-axis mill, then lens, edge blackening to prevent light leakage, and finally curing under heating elements. Every single piece is then run through automated optical inspection, where laser profilers and vision systems verify that the geometry is within spec down to the micron. That's 8 more steps. And we haven't even touched the displays yet. Section 3, the micro-OLED displays. This is where Apple spent the real money, and this is the component that makes or breaks the entire device. Each Vision Pro has 2 micro-OLED displays made by Sony. Each one measures just 1.25 inches, literally the size of a postage stamp, but packs enough pixels to exceed the resolution of a 4K television. Combined, that's 23 million pixels with a pixel pitch of just 7.5 microns. To put that in perspective, you could fit 54 Vision Pro pixels inside a single iPhone 15 Pro pixel. The pixel density hits around 3,400 pixels per inch. Nothing else on the consumer market comes close. But here's what most people don't realize. These displays aren't just slapped onto a circuit board. The backplane is silicon. Apple designed the silicon architecture, and Sony handles the OLED deposition, encapsulation, and driving circuitry on top of it. The manufacturing starts the same way computer chips are made, with the Czochralski process, where a seed crystal is dipped into molten silicon to grow a massive cylindrical ingot, which is then sliced into ultra-thin wafers, patterned and etched at the nanometer scale. Then the organic OLED materials are deposited on top in ultra-clean conditions. Because you can't deposit individual red, green, and blue subpixels at this scale in mass production, they create white light and pass it through color filters. That process alone eats 70 to 80% of the light output, which is why these displays need to pump out thousands of nits of brightness just to look normal to your eye. Sony produces these exclusively in Japanese fabrication facilities, and yield rates are a constant battle. Any defect at any layer means the entire display is toast. Apple reportedly pays $228 per display, meaning $456 just for the two screens. That alone is nearly a third of the total $1,542 bill of materials. Section 4. The optics. Between those displays and your eyes sits a 3-element pancake lens system, and this is where Apple's optical engineering borders on witchcraft. Pancake optics work by folding the light path, bouncing light between polarized surfaces and reflective layers to dramatically reduce the distance between the display and the lens. This is what keeps the Vision Pro from being the size of a shoebox. The key innovation is something called a quarter-wave plate, or QWP. This component converts linear polarization to circular polarization, essential for the light folding trick to work. The problem? A quarter-wave plate can't be bent or deformed, so Apple figured out a way to embed it between two cylindrical surfaces, allowing the QWP to remain flat while being cylindrically rolled inside the lens assembly. The first lens is literally split into two parts by this cylindrical cut. It's a solution so elegant that it's protected by Apple patents. Each lens element has intentionally uneven thickness, thicker on one side, thinner on the other, to optimize the field of view and eye relief distance. After assembly, every single optical unit goes through precision alignment using reflective markers and laser metrology to ensure perfect positioning relative to the displays. Section 5. The chips and sensors. Now let's talk brains, because this headset has two of them. The Vision Pro runs on two chips, the Apple M2 and the custom-designed R1. The M2, the same chip that powers the MacBook Air, handles the operating system, apps, computer vision algorithms, and graphics. It's manufactured by TSMC on a 5-nanometer process, packing an 8-core CPU, a 10-core GPU, and a 16-core neural engine with 16 gigabytes of unified memory. But the real star of this device is the R1 chip. This thing is purpose-built for one single job: processing data from every sensor on the device and streaming images to the displays within 12 milliseconds. That's 8 times faster than the blink of an eye. It pulls data simultaneously from 12 cameras, 5 sensors, and 6 microphones. Yes, and it does it with 256 gigabytes per second of memory bandwidth. Those 12 cameras include 2 high-resolution main cameras, 6 world-facing tracking cameras, 4 infrared eye tracking cameras inside the headset, plus a true depth camera and a LiDAR scanner. The LiDAR uses direct time-of-flight technology. It shoots a 940 nanometer laser beam and measures how long the reflection takes to come back, mapping your entire room in 3 dimensions. Section 6. The EyeSight display, audio, and soft goods. Here's a feature that blew people's minds when Apple first announced it. and then frustrated them when they actually tried using it in real life. The EyeSight display is an outward-facing OLED screen on the front of the headset that shows a digital rendering of your eyes to people around you. The idea is to make the wearer seem less isolated. But here's the engineering behind it. Apple layered a lenticular lens on top of that OLED panel, the same technology used in those holographic postcards you had as a kid. The lenticular ridges display different images at different angles, creating a stereoscopic 3D effect of your face. Section 7. Final assembly and testing. Everything converges at Luxshare's factories in China. This Shenzhen-based manufacturer is the sole assembler of the Vision Pro, a company that earned Apple's trust by being willing to test what insiders call crazy ideas in prototyping and manufacturing. Luxshare beat out even Foxconn for this contract. During final assembly, micro-welding secures the aluminum frame components together. The custom micro-OLED displays and 3-element lens system are placed with extreme care. Any misalignment at this stage ruins the entire optical calibration. The 12 cameras, LiDAR scanner, and all sensor arrays are mounted and connected. Then the external battery, a machined aluminum pack weighing about 12.5 ounces with a 35.9 watt-hour capacity. Section 8. The real cost. So here's the thing no one talks about. That $1,542 bill of materials? That only covers raw parts. It doesn't include the billions Apple spent on research and development over 7 years. It doesn't include assembly labor, packaging, shipping across the Pacific, import duties, warehousing, retail staffing, marketing campaigns, software development, or the ongoing engineering of Vision OS. When you factor all of that in, Apple's margins on this device are far thinner than people assume, especially when they're only shipping around 400,000 units a year. For context, Apple ships over 200 million iPhones annually. The Vision Pro isn't a cash cow, it's a statement piece. It's Apple proving that the future of spatial computing can be built today. And make sure you subscribe so you don't miss the next episode of The Making, where we tear apart the manufacturing secrets behind the world's most incredible technology. See you in the next one.